let's now solve the parts of the ellipse whose center is at point HK. So that will be the third problem. So for the third problem, we have here the general equation 4x squared plus 16y squared minus 16x minus 32y minus 32 equals 0. And to convert this one into its standard equation, we would have to rearrange the terms. I'll write first the terms containing x, 4x squared, followed by negative 16x. Next is the terms containing y. We have here 16y squared minus 32y. And as for the constant, I would transpose that one to the right side of the equation, so thereby making it a positive 32. Next, perform completing the square, but before we do that, we should factor out first the coefficients of x squared and y squared. So I would have here 4 times x squared minus 4x plus 16 times y squared minus 2y equals 32. So next, let's now perform the completing the square by adding a constant to these two quadratic equations. So I would have here 4 times x squared minus 4x plus the constant plus 16 times y squared minus 2y plus the second constant. Then on the right side, I will add the two constants to balance the equation. Now to solve for the first constant, so we have here the coefficient of the middle term, that is negative 4, divided by 2, that would be negative 2. Square of negative 2 is positive 4. So that will be the constant. We will do the same process in this quadratic equation. We have here the coefficient negative 2. So that is the coefficient of the middle term divided by 2, that is negative 1. Negative 1 squared is positive 1. So on the right side, we would add here the product of 4 and the constant, that is 16. And 16 and the constant, that would be 16 also. Next is, we would have to make this perfect square binomial into a factored form. So to do that, I would have to take the square root of x squared, that is x, copy the sign of the middle term, that is minus, then square root of 4, that is 2, then place an exponent of 2. We would do the same on the second term, so I would have here 16 multiplied by y minus 1 squared. Then on the right side, 32 plus 16 plus 16, that would be 64. Next step, or the last step, so that would be dividing the both sides of the equation by 64, thereby making the standard equation equal to x minus 2 squared over 16 plus y minus 1 squared over 4 equals 1. So we now have the standard equation of the ellipse. We can identify here the value of the semi-major and semi-minor axis. I would equate here 16 with a squared since it is the larger denominator. So a squared equals 16. Taking the square root on both sides, a would be equal to 4. I would equate b squared with 4. Then taking the square root on both sides, b here would be equal to 2. So we now have the semi-major and semi-minor axis. And for this ellipse, its major axis is horizontal, since we have here a squared together with the term containing x. So before we can solve the parts of the ellipse, let's identify first the coordinates of the center, or the h and k from this equation. So to do that, I would compare this equation with x minus h squared over a squared plus y minus k squared over b squared equals 1. So if we compare these two equations, I can say that h is equal to positive 2 since they have the same sign, and k here is positive 1 since they also have the same sign. So we can now solve for the coordinates of the center. So that would be coordinate hk. Therefore, the coordinate of the center here would be 2, 1. Next, for the length of the major axis, that is 2a, this would be 2 times 4. The length of the major axis would be 8. For the length of the minor axis, this is 2b. This is 2 times 2. 2 is the value of b. So we have here the length of the minor axis equal to 4. As for the coordinate of the vertices or the endpoints of our major axis, we have here h plus ak. H plus a would be 2 plus 4, that is 6. Then k is 1. Followed by the next point, h minus a, that will be 2 minus 4, that is negative 2, 1. For the coordinate of the co-vertices or endpoints of our minor axis, we have here h, then k plus b. H is 2, k plus b would be 1 plus 2, that is 3. And the next point is h, that is 2. K minus b is 1 minus 2, that is negative 1. Next, for the coordinates of the foci, let's solve first for the value of c. So using the equation square root of a squared minus b squared, and plugging in their values, we have here 16, square root of 16 minus 4. So that would be square root of 12. So square root of 12 in decimal form would be 3.46. So the coordinates of the foci here would be h plus c. So that would be 2 plus 3.46, that is 5.46. Then k, that is 1, followed by h minus c. That would be 2 minus 3.46, that is negative 1.46. Then k, that is 1. So this is our coordinates for the foci. Next, for the eccentricity, so it is still c over a. C is 3.46, then divided by the value of a, which is 4. The eccentricity here would be equal to 0.87. Next is the length of the latus rectum. This is still 2b squared over a. Plugging in the value of b and a, I would have here 2 times 2 squared over a is 4. So this 2 squared and 4 cancels out. Therefore, the length of the latus rectum is equal to 2. Next, for letter I, let's solve for the value of d. This is still a over e. A is 4, e is 0.87. So 4 over 0.87 would be equal to 4.60. Now, for the equation of the directrices, so we have here h plus d and h minus d. So the first equation here would be h plus d, that is 2 plus 4.60, that would be 6.60, followed by h minus d, that is 2 minus 4.60, that would be equal to negative 2.60. So these are the two equations for our directrices. As for the endpoints of the Latera recta, so we have here h plus c, that is the x-coordinate of our foci, that would be 5.46. Then k plus b squared over a. B squared over a is half of the latus rectum, which is 1, since the latus rectum is 2. So we have here k plus 1, that would be 2, followed by 5.46. This time k minus 1, that would be 0. So next pair is h minus c, that would be this value here, which is negative 1.46. K plus 1, that is 2. Next is h minus c, still negative 1.46. Then k minus b squared over a is 0. So here are our endpoints of our Latera recta. So if we try to graph that one, we would have this ellipse below. So we have here the center at 2, 1. Endpoints of our major axis, 6, 1 and negative 2, 1. endpoints of our minor axis 2, 3, 2, -1, coordinates of our foci 5.461, and this one here is not indicated, but this should be at -1.461, and the 4 endpoints of our lateral rectum. This is the first, second, third, fourth, and lastly, equations for our directrices. So here is our x equals positive 6.60. On the left side, we have here x equals negative 2.60. Let's now solve the parts of the ellipse whose center is still at HK, but this time the major axis of the ellipse is vertical. We have here the last problem. We have here the general equation 9x squared plus 4y squared minus 18x plus 16y minus 11 equals 0. So to convert that one into its standard equation, again, we would rearrange the equation. I will write down first the terms containing x. I will start with 9x squared followed by negative 18x. Next is the terms containing y. That would be 4y squared plus 16y. Then as for the constant, I would transpose that one to the right side. So we have here 11. Next, let's factor out the coefficients of x squared and y squared. So I have here 9 multiplied by x squared minus 2x plus 4 multiplied by y squared minus, or sorry, plus 4y equals 11. Next, let's perform completing the square by identifying the constant. So I would have here x squared minus 2x plus the first constant plus 4 times y squared plus 4y plus the second constant. So this should be 11. Then on the right side, 11 plus the two constants we've added on the left side. So to identify the constant, so for the first constant here, we have here negative 2 divided by 2, that is negative 1. Negative 1 squared is positive 1. As for the second constant, we have here the coefficient of the middle term, positive 4, divided by 2, that is 2. Square of 2, that would be positive 4. So the value that we will add on the right side will be the product of 9 and 1, that would be 9, and the product of 4 and 4, so that would be 16. So simplifying, let's make this quadratic equation into a binomial form. So I would have here 9 multiplied by x minus 1 squared plus 4 times y plus 2 squared. Then on the right side of the equation, 11 plus 9, that is 20, plus 16. So I would have here 36. Dividing both sides by 36, the standard equation of this ellipse would be x minus 1 squared over 4 plus y plus 2 squared over 9 equals 1. So we can now identify the length of the semi-major and semi-minor axis. Since 9 is the larger denominator, I would equate that one to a squared. Then solving for the value of a, so a here would be equal to 3. As for the length of the semi-minor, I would equate b squared to 4, which is the smaller denominator. Take the square root on both sides. B here would be equal to 2. And as I mentioned a while ago, the major axis of this ellipse is vertical, since a squared is located on the term containing y squared. Next, let's identify the coordinates of the center, specifically the coordinate h and coordinate k. To do that, let's compare this standard equation with x minus h squared over b squared plus y minus k squared over a squared equals 1. So comparing these two equations, we can say that h here is equal to positive 1 since they have the same sign. And for k here, we have here negative. This one here is positive. Therefore, k is negative 2. Therefore, the coordinates of the center of this ellipse would be 1, negative 2 by plugging the values of h and k. For letter B, length of the major axis, this is 2a, 2 times the value of a, that is 3. The length of the major axis would be equal to 6. For the length of the minor axis, 2b, so b here is 2, therefore the length of the minor axis would be 4. As for the coordinate of the vertices, since the major axis is vertical, we will have these coordinates. Let's start with h plus k plus a. So h is 1, then k plus a would be negative 2 plus 3, that would be positive 1. So negative 2 plus 3 is positive 1. Next is h minus ka. H is still 1. K minus a would be negative 2 minus 3. So the y coordinate here would be negative 5. Next, for the coordinate of the co-vertices or endpoints of our minor axis, we have here h plus b. So h, that is 1, plus b, that is 2. So 1 plus 2 is 3. Then k is negative 2, followed by h minus b, 1 minus 2, that is negative 1. Then the y coordinate is still k, which is negative 2. So here are the coordinates. Now for the coordinates of the foci, let's solve for c. C can be solved using the equation square root of a squared minus b squared. Plugging in the values of a squared and b squared, I would have here square root of 9 minus 4. That would be square root of 5. Square root of 5 in decimal form would be 2.24, rounded off to 2 decimal places. So we can now solve for the coordinates of the foci. So we have here h, that is 1, then k plus c, 2.24 plus negative 2, or that would be, negative 2 plus 2.24. The answer to that one would be 0.24. Next is h, that is still 1, then k minus c, negative 2 minus negative 2.24, that would be negative 4.24. So these are the coordinates of the foci. Next, for the eccentricity, this is still c over a. C is 2.24 divided by the value of a, that is 3. So the eccentricity of the ellipse would be equal to 0.75. So this is rounded off to 2 decimal places. For the length of the latus rectum, this is still 2b squared over a. So I would have here 2 times 2 squared divided by 3. So I would have here 2 times 2 squared, that would be 8. 8 over 3 is 2.67, rounded off to 2 decimal places. Now for the equation of the directrices, let's solve for d, that is a over e. So a is 3 divided by 0.75. 3 over 0.75 would be equal to positive 4. Therefore, the equation of the directrices would be k plus d. That would be negative 2 plus 4. So the first equation would be y equals 2. This is y sub 1. Next is y sub 2. That would be k minus d. That is negative 2 minus 4. So y sub 2 would be negative 6. For the last part, endpoints of the Latera recta, let's identify the b squared over a, or half of the half of the length of the latus rectum. So half of the length of the latus rectum would be 1.34, rounded off to 2 decimal places. So I would have here h plus 1.24, that would be 1 plus 1.34, that is 2.34. Then k plus c, is this value here, which is equal to 0.24. And next point here is h minus b squared over a, that is 1 minus 1.34. That will be negative 0.34. Then k plus t is still 0.24. Now for the last pair, we have h plus b squared over a, that is 2.34. K minus c is negative 4.24. And for the last point, h minus b squared over a, that is negative 0.34. K minus c is negative 4.24. So these are the endpoints of the Latera recta. Now, if you try to graph the parts of the ellipse, we would have this figure below. So it is centered at 1, negative 2 endpoints of our major axis or our vertices. So here is 1, 1 and 1, negative 5 endpoints of our minor axis. Negative 1, negative 2, 3, negative 2. Coordinates of our foci, we have here 1.24, 1, negative 4.24. Endpoints of our Latera recta, we have here the 4 endpoints. This is the first, second, third, and fourth endpoint. And for the last one, we have here the equations for our directrices. So the equation here above the ellipse is y equals 2. And the equation here of the line below the ellipse would be y equals negative 6.